Assalamualaikum and good morning to madam and my dear classmates. Today I will present about sieving process. Firstly, the process of screening spread particles according to a specified size. Then sieving process is originated in Egypt. This process is used to separate grains. Nowadays, they use high-tech methods such as laser diffraction to determine particle size. After that, there are other methods used such as centrifuge technique and sedimentation. Sieve most commonly use device to particle analysis size. However, sieve analysis is the method of particle size analysis using which we determine amount of particles of different size present in the soil sample. Sieve analysis is done for coarse grain size. In this method, soil is sieved through set of sieve. Size of this opening give the sieve their name, which called is sieve number. Sieve which the opening of 4.75 mm. It does not matter that 4.75 mm sieve similarly has 600 microns of sieve. The grain size analysis test is performed to determine the percentage of each size of grains that is contained with a soil sample. And the result of the test can be used to produce the grain size distribution curve. Sieve analysis is a method that is used to determine the grain size distribution of soils that are greater than 0.075 mm in diameter. It is usually performed for sand and gravel but cannot be used as the sole method for determining the grain size distribution of finer soil.
I'm here to continue about the procedure of the sieve analysis. The sieve analysis is divided to two, namely is dry and wet. The sieve number is 4.75 mm. The grain size greater than 4.75, this portion called gravel fraction. The portion of soil which grain size smaller than 4.75, this portion is called sand fraction. This way, coarse grain soil are divided to two categories. One is gravel having grain size greater than 4.75, and second one is sand having grain size. Then for sieve analysis for a sample, we need two set of sieves, one for gravel fraction and another for sand fraction. For gravel fraction, we request for sizes 80 mm, 40 mm, 20 mm, 10 mm and 4.75. This set is called set of coarse sieve. Second set of sieves for sand fraction, we request sieve sizes 2 mm, 1 mm, 600 micron, 212 micron, 150 micron and 70 micron. If it didn't mention, 1 mm is equal to 100 micron, which is we call this set of sieves is called set of fine sieve. We continue with procedure. First, calculate the total of mass before place the aggregate into the sieve. Second, you need to prepare a set of sieve and arrange it in the sequence. Third, the sieve are stand one over other, and grain sizes of their measure opening from bottom to the top, which means the sieve of the largest opening is kept the top. The pan which has no opening is placed below the bottom of the sieve. The first sample is placed in the top sieve, and the lid to cover this arrangement placed at the top sieve. Then the whole management are placed on the mechanical shaker, and they shake in 10 minutes until we will know it is located at the top or the bottom or below the bottom, and the arrangement are taken out. Then take a 10 until 15 minutes to identify weight of the aggregate and read the weight with W1, W2, W3, W4, W5 and W pen. By using the British Standard 1992, when you want to know it have a middle limit, whether or not if are appropriate to use that aggregates in the construction.
So, we move on to the calculation process. Based on the procedure described, the way to identify the aggregate mass is by subtracting the sieve mass, added filtered aggregate, and the sieve mass only, or by directly weighing the aggregate mass. Each such aggregate mass will be represented by the letters W1, W2, and so on. Next, we will calculate the percentage retained on sieve by dividing the mass of aggregate that has been filtered according to the sieve. For example, W1 by the total mass of aggregate that has been weighed before the sieving process that has been done and multiplied by 100. So we can see the calculation for the mass of aggregate on each sieve, including the mass of aggregate on the pen. Next step is to find the cumulative percent of aggregate retained in each sieve. To do so, add up the total amount of aggregate that is retained in each sieve and the amount in previous sieve. So this is an example of how to add on each layer of sieve. P represents the percentage retained on the sieve. After that, we will calculate the final percentage retained, or also known as passing percentage retained. Percent final is the amount of material from a sample that is smaller than certain size and represent the percentage of material from the total sample 100% that will pass through the current sieve. To facilitate our understanding, this final percentage can be calculated by subtracting the total sample, which is 100%, with cumulative percentage retained, represented by the letter C. So we can look at the calculation table required to get all the percentage. Make sure you all memorize each formula. Now, we will move on to the description of the table and graph.
Next, we can see at the table that we record after calculating the cumulative retained with using the formula. Sieve analysis proved that it can be used to separate the aggregates to the particle of size. The number of size describe what sieve aggregate fall through to the next. The result should be calculated and reported as the cumulative percentage by width of the total sample. Then, the percentage by width of the total sample passing through one sieve and retained on the next smaller sieve to the nearest 0.1%. The result of the sieve analysis may be recorded graphically to get the good quality of aggregates. Last but not least, based on the analysis, we conclude that this is a simple way to determine the particle size distribution of coarse aggregates. This analysis procedure can be used by people, and the process also guarantees good quality in producing the aggregates. It will help our structure to be stronger and tough. That's all from me. See you next time. Assalamualaikum warahmatullahi wabarakatuh.
Assalamualaikum and good morning to Madam and to my dear class. Today, we will present about the topic of slump test. As we know, the concrete slump test is used to determine of concrete workability or fluidity. Also, indirectly to determine of concrete consistency of stiffness. The concrete slump test is used for the measurement of a property of fresh concrete. The test is an empirical test that measures the workability of fresh concrete. More specifically, it measures consistency between batch. The test is popular due to the simplicity of apparatus used and simple procedure. The slump test is used to ensure uniformity for different loads of concrete under field condition. Then, the slump test is perhaps the most widely used because of the simplicity of apparatus required. Slump test also indicates the behavior of compacted concrete cone under the action of gravitational force. Change in the value of slump obtained during the job may indicate change in material in the water content or in the proportions of the mix, so it is useful in controlling the quality of the concrete produced. The slump test is used to ensure uniformity for different loads of concrete under field conduction. Next, I will show you the apparatus that must be in the test. The first one is slump cone. The height is 30 cm, base diameter 20 cm, and the top diameter is 10 cm. The second one is tamping rod. Tamping rod must be steel, length 60 cm, diameter 16 mm. And the next one, measuring tape, scope, base plate, and brush. Then the material is cement, fine aggregate, coarse aggregates, and water.
Let me show you the procedure. Slump cone test is a simple and popular test extensively used at sites to assess the workability of the concrete mix. The test should be conducted at the commencement of the concreting operations or whenever the workability of the concrete changes. The apparatus for conducting the slump test essentially consists of a metallic mold in the form of rostrum of a cone with a base plate. A steel tamping rod of 60 mm diameter and 60 cm height is to be used for compacting. The internal surface of the mold should be truly clean of moisture and any hardened concrete before commencing the test. The mold is placed on a smooth horizontal rigid and non-absorbent surface. It then filled in with the thickness of each layer being approximately 1/4 of the height of the mold. Each layer should be tamped 25 times evenly. Use the rounded end of the tamping rod such that strokes are uniformly distributed over the cross-section. After the top layer is tamped, the concrete is leveled with a towel so that the mold is filled exactly to the top. The mold is then removed by raising it gradually. The concrete will subside. This subsidence is known as slump. This operation shall be carried out without any jerks or vibration and within a period of 2 minutes after completion of final tamping. The difference in level between the height of the mold and at the highest point of the subsided concrete is measured. The subsidence measured is the slump of the concrete. The slump may be either a true slump or shear slump or a collapsible slump. The true slump is the desired form or slump that we required. In harsh mixes, the concrete slides down in an inclined plane. This is known as shear slump. In collapse slump, the concrete collapses as soon as the cone is removed. It usually occurs in very wet mixes. The concrete demonstrating a collapse slump is considered unsatisfactory. In case of slump results beyond the specified limits, the mix proportion needs to be adjusted, especially the water content. The slump can be varied by changing the proportion, size, and the combination of various sizes of the aggregates.
I want to continue about calculation of slump test. H1 is original height of slime when the detail issued from the cone test, so we can find it when the slime test has not fallen yet. While H2 is height of the slime issued from the cone test, and the height of the slime also will be slightly reduced. R is the radius of the cone. When talking about the cone, we must calculation the volume for the slime test. They will be 2V because it has a different height. That is the original height and the height after we leave slime container. So the basic formula of cone is 1/3 pi times R2 times H1, and for volume 2, 1/3 pi times R2 times H2. So to find V1 and V2, we must use this formula and just insert the value of H1 and R1 for V1 and H2 and R2 for V2 by following the question given. After get the answer of V1 and V2, we need to minus between it to get the final answer. Then we proceed how to calculate the mass of the concrete. So the formula is volume. Usually the density you can see it in the question, so we can times it with the value. And this also the example how to calculate it. In addition, we continue how to calculate the wastage. As usually, the wastage will be set at 20%. So 20% times the mass of concrete plus wastage. So we will find the answer. Moreover, we need to calculate the total weight of the concrete. The formula is the mass of concrete plus wastage. So we will find the answer. The concretes have many of grades such as 20, 25 and others. If we use the concrete that's grade 25, so the ratio is 1:1.5 ratio 3. So total ratio for the concrete grade 25 is 5.5. Ratio 1 is ratio for the cement. Ratio 1.5 is ratio for the sand. And the ratio 3 is ratio of the aggregates. Then all ratio times with the total weight of the concrete. So the formula of all these is the each ratio times with total weight of cement. It is because the water have a determined value is 0.05.
The consistency of slum test is first very low consistency. The slum test is 0 to 25 mm, and then the slum inchi is 0 to 1. Second, low consistency. The slum test is 25 to 50 mm, and the slum inchi is 1:2. Then, medium consistency is 50 to 100 mm slum test, and then the inchi is 2 to 3. And then the high consistency is 100 into 175. The slum inchi is 4 to 7. The test for workability of concrete slum cone. It is advisable to assess the workability of concrete mix using a slum cone. Ensure that the cone is filled in a paper manner as indicated. Notice the type of slum, shear and collapse slum are undesirable. The conclusion, the slum test is a way to measure the workability of concrete. A small slum means the concrete is stiff. A massive slum implies the concrete will flow easily. The slum test is performed by packing a metal cone with the concrete according to a specified procedure, then lifting the metal cone off the pavement and measuring the fall of the top of the concrete.
Assalamualaikum warahmatullahi wabarakatuh, and good morning to Madam, Doctor and my fellow friends. Today I am Nurhani Safia binti Muhammad Hafizi, and my group want to present about compaction factor test. Compaction factor test is the workability test for concrete conducted in laboratory. The compaction factor is the ratio of weights of partially compacted to fully compacted concrete. It was developed by Root Research Laboratory in United Kingdom and is used to determine the workability of concrete. The test is used for concrete which have low workability, for which slum test is not suitable. It is also designed generally for use in laboratory and sometimes used at sites. The compaction factor apparatus consists of upper hopper in dimension. The top internal diameter is 25.4 cm, bottom internal diameter is 12.7 cm, and internal height is 27.9 cm. A fixed lower hopper of dimensions is the top internal diameter is 22.9 cm, bottom diameter is 12.7 cm, and internal height is 27.9 cm. The cylinder of internal diameter is 15.2 cm and internal height is 30.5 cm. The distance between upper and lower hoppers and cylinder is 20.3 cm. A steel tamping rod of 16 mm diameter and 60 cm height is also be used to compact the concrete.
So I'm in charge on the procedure of compacting test. The sample of concrete to be tested is placed in the upper hopper up to the brim. The trap door is open so that the concrete falls into the lower hopper. Then the trap door of the lower hopper is open and the concrete is allowed to fall into the cylinder. The excess concrete in the cylinder is level. The outside of the cylinder is wiped clean. Now, the cylinder filled with concrete is weighed. This weight is known as the weight of partially compacted concrete. Then empty and clean the entire cylinder. Now, fill the cylinder with concrete and layers where each approximately is 5 cm deep. Once fully filled, the top surface is level off. The outside of cylinder is white. Now, with the cylinder, this weight is known as the weight of fully compacted concrete.
And the formula is compaction factor equal to the ratio of the weight of partially compacted concrete with the weight of fully compacted concrete. That means W1 minus W or W2 minus W. The compaction factor values range from 0.7 to 0.95. Then we see at the compaction factor value and degree of workability is calculated with the helper table. At the table we can see degree of workability have very low, low, medium and high. And compaction factor value divide by 2, small apparatus and large apparatus. The small apparatus very low is 0.78 and large apparatus is 0.80 and low is 0.85 small, 0.87 large. Medium is 0.92 small and 0.935 is large. And the last one is height, 0.95 small and 0.95
By above research, we can calculate that the compaction factor of fresh concrete mix is 0.77, while for the normal range of concrete, the compaction factor lies between 0.8 until 0.92. Hence, the degree of workability is very low. That means roads are vibrated by power-operated machine. The relationship between workability and compacting factor is higher than compaction factor. Highest is the workability. This test is particularly useful for drier mixes for which the slime test is not satisfactory. This should be conformed to BS 1881-5103. Maximum size of aggregate will be 1.5. Test duration is 150 seconds from the commencement of test. The sensitivity of the compaction factor is reduced outside the normal range of workability and is generally unsatisfactory for compacting factor greater than 0.92. The test measures the unusual compressive strength of concrete cubes which are made, curl and test to various requirements. It does not measure or predict in any unique way the strength of the concrete in the structure. The test is simply a quality control test which measures the consistency of concrete in terms of on particular property compressive strength using an arbitrary test method, testing the same concrete under different conditions, for example, specimen size, specimen shape, carrying temperature, loading rate, and other will give different results. The objective of this test conducted to determine the strength of concrete. 2. Compression strength test is carried out using cube test. The theory of this test is two types of tests are carried out to determine whether the concrete products does follow the specification given. They are competing factor test length test and weight. Consistometer tests which are for mixed concrete, whereas for hardened concretes, they are cube compression test and flexible compression beam test. Hardened concrete test is usually carried out when concrete is at age 3, 7, 14, 21, and 28. Concrete strength increase according to its age. In general, concrete would have acquired 70% strength on the 7th day. The apparatus of this test is concrete cube size 150 mm times 150 mm. 2. Compaction steel rod with size 25 mm times 25 mm. 3. Oil or grease. Then compaction test machine. Last is trowel.
Next, we go to the procedure of cube test. Generally, the specimen shape in cube and cylinder are used for testing the compressive strength of concrete. The standard size of cube specimen volume is 150 mm, while the cylinder specimen diameter is 150 mm and 300 mm in length. Then, the fresh concrete is prepared into the required grades and respective mixed proportion. Firstly, make sure the sections are bolted tightly and mold face are coated with the oil. Then, fill in the mold in 3 layers evenly and temp 35 times for cube mold 150 mm or 25 times for cube mold 100 mm size for each layer. Or vibration table may be used instead of tamping rod. After that, finish or surface using the trowel and mark the cubes by scoring on the top, just before concrete sets suitably for future identification. Then, leave in the mold with concrete for 24 hours under damp sinking. After 24 hours, strip the concrete cube and weigh for dry cube and place all the cubes into the curing tank for 7 days. After 7 days, remove the test cube from the curing tank and wipe off surface water with the damp cloth. Wick the wet cube. Then, place the cube centrally on the lower platen of the compression test machine with the raw top surface of the test cube facing toward you. Then, lower the top platen onto the cube and make sure the test machine is set to the correct loading. Close the test machine door to avoid any injury. Lastly,
record all the data and repeat for concrete cube based on the age of day mark. Notes also the type of a failure and appearance of crack.
So I'm in charge on the calculation of cube test. The load is applied at a rate of loading of 400 kg per minute for the 150 mm specimen and at a rate of 180 kg per minute for the 100 mm specimen. Finally, note down the load at which cylinder fails by developing cracks. Now, measure the distance between the line of fracture and the nearest support. Consider this as 1. If I is greater than 200 mm for 150 mm and 130 mm for 100 mm specimen, then flexural strength or modulus of rupture FB is calculated by equation FB is equal to P into L divided by BD square. If I is less than 200 mm and greater than 170 mm for 150 mm and less than 133 mm and greater than 110 mm for 100 mm specimen, then flexural strength or modulus of rupture FB is calculated by equation FB is equal to 3PA divided by BD square, where B is the width of the beam in millimeter, D is the failure point depth in millimeters, L is the supported length in millimeters, P is the maximum load applied to the beam in kilograms, and is the distance between the line of fracture and nearest support in millimeter.
Now we move to the observation of results. So we can see that the table have been divided into several sections that have a few numbers. We must know every part in the table first. Number 1 is days, number 2 is cube mass or kilogram, number 3 is compression result, number 4 is calculation theory, number 5 is result, number 6 is dry, number 7 is wet, number 8 is main load or kilonewton, number 9 is stress or newton or meter square, number 10 is base rate, and number 11 is density. Next, this is an example for a table that have been filled in with the data of compression results for 7 days and 28 days. Then, we go through the failure of cubes. Okay, this failure is called satisfactory failures because it is maintaining the original shape and the cracking that occurs is not excessive and the cracking is according to the required standard. After that, we move on to the unsatisfactory failure. The cracks that is occurs too much and do not maintain the original shape. Therefore, it is an unsatisfied cube. Last but not least, the conclusion is this video introduced cube compression test. We presented information and the intro, objective, apparatus, procedures and calculation about the cube compression test. First of all, we would like to thank our lecturers who taught us to do this video report. Through this activity, we were able to cooperate and able to finish it in required time. That's all from us. Thank you. Assalamualaikum warahmatullahi wabarakatuh.
Assalamualaikum warahmatullahi ta'ala wabarakatuh. Welcome to this work solution presentation introducing timber product standards. A standard is a document that describes minimum acceptable levels of performance or practice. Australian standards cover timber design and construction practice, the required performance of timber and wood products, and means of assessing the performance or characteristic of those products. This presentation is looking specifically at standards that define the required performance of timber and wood products. Timber and wood product standards generally do three things. They establish the minimum acceptable performance for products. That's first. They provide great definition for individual timbers elements, and lastly, they may specify means of verifying product performance and of marking that performance on the piece. The content of individual standards vary, but they usually focus on a particular product. For example, a standard may focus on appearance grade, hardwood, machine grade, structural softwood, or structural glulam. Groups of product standards exist, so they exist for round timber, poles, saw on structural products, engineer wood products, and lastly for appearance grade products. The Australian Standard 3818 group of standard covers many of the application for structural round timber. For example, building poles are grade 2 AS 3818.10 timber heavy structural product, visually grade building poles.
The procedure is material preparation. Sample prepare 150 mm for each type of woods and mark in 3 points A, B, and C with the equal center. Moisture meter testing. To use an electric moisture meter, turn it on and make sure select the type of material mode and press the 2 metal pins into the wood with a little pressure. You don't need to insert the pin into the wood or apply any extreme force. Record data before and after drying oven testing. After it is oven dry testing, the oven test. The simplest way to check the moisture content of a piece of wood is to wedge a piece of wood, dry it in an oven, then measure it again to see the difference in weights. This is the most accurate way to test moisturized content in wood, but it's also time consuming. Drying about 24 hours with 100 Celsius.
Next, we move to the calculation process. Calculation divided to two methods, which for moisture meter and oven dry test. Moisture meters are widely used in the industry. No grain industry can function without these meters. Grain or product moisture has to be determined at some time before, after, or during a process for process or product control. This must be a spot determination which can only be done with a suitable meter. Intelligently used, a moisture meter is a thus a boon to the industry. If used with implicit trust without questioning, it can be a menace. The calculation process to know the moisture is A plus B and plus C and divide with 3. A, B, and C equal to types of woods. It is very simple calculation test for me. Next, the oven dry test combined with the prompt or stress test is a very useful tool for the kiln operator to have at his or her disposal. Often the kiln operator is asked to defend the accuracy of moisture meter measurement, or a customer simply does not believe moisture meter readings. In other situations, the operator may want to verify meter readings for his own peace of mind. For a situation in which moisture meter will give the same information more quickly and with little effort, then they are the tools of choice. However, it is important to always remember that the oven dry moisture content is what the meters are trying to estimate. In the solid wood products industry, the most often defined moisture content on a dry basis. This means that the moisture content is defined as MC equal to initial weight minus oven minus dry weight divide oven minus dry weight and times with 100%. If there are a number of samples, I prefer to use a spreadsheet to calculate moisture content rather than a calculator. It is easy to go back and check for errors in the data entry. After calculating a value, make sure it stands compared to what you measured. If using a spreadsheet, put in some simple known values to check the calculation. For example, if you enter the initial weight of 150 grams and a final weight of 100 grams, your calculation should give a 50% moisture content. So, the oven dry test can be a useful tool not only for verifying the readings from electronic moisture meters, but also for understanding what is happening inside of the wood as it dries. In some cases, even the oven dry test can be in error if the wood contains a high concentration of volatile compounds other than water. The correct moisture content is important for product quality, and the oven dry test is an important QC tool. That's all from me. Thank you.
Lastly, we go through at observation and result. After we complete to the calculate, we need to fill in the data table for each type of wood. Example type of wood is softwood, light hardwood, medium wood, heavy wood. Next, in the table data have method 1, that is moisture meter. Method 2 is dry oven. And record the reading fresh wood and dry wood at method 1, moisture meter. And also record the wet width before put into the oven and dry width after the oven dry for method 2, dry oven test. Then, must find the moisture content for each wood using the formula at calculation. The conclusion. The moisture content level is expressed as a percentage of the oven dry width of the timber. Growing trees will typically be stated as having a moisture content of more than 100%, and even at a moisture content of around 25% water will be partially filling the structural wood fiber. Entirely, as the timber dries, this moisture is lost, lowering the width although not affecting the timber dimensionally. However, if the bond moisture in the empty wood cells walls also dries without some control, the fibers contract and shrinkage occurs. Conversely, if dry wood is allowed to absorb moisture, then the reverse of this process occurs, creating dimensionally increase and distortion. Against this background, unless the component required is going to be used in a design for a wet environment, it is a fundamental that wood must have been dry to a target moist content level before use. This will ensure minimal and restrained movement. That's all from us. See you next time. Assalamualaikum warahmatullahi wabarakatuh. Assalamualaikum to Madam and my dear classmate. Today we will present about tensile test. Firstly, tensile properties are used in selecting materials for various applications. Material specification often include minimum tensile properties to ensure quality. Tensile tests must be made to ensure that materials meet this specification. The tensile stress-strain curve can be used to predict a material behavior under loading forms other than the uniaxial tension. Then, tensile tests are performed for several reasons. The result of tensile tests are used in selecting materials for engineering application. Tensile properties frequently are included in material specification to ensure quality. After that, tensile properties often are measured during development of new materials and processes, so that different materials and processes can be compared. Finally, tensile properties often are used to predict the behavior of a material under form of loading other than unusual tension. Next, objective of tensile test. Effectiveness and quality of materials used in manufacturing play a crucial role in bringing about marketplace success. Tensile tests help determine the effectiveness and behavior of a material when a stretching force acts on it. These tests are done under optimum temperature and pressure conditions are determine the maximum strength or load that the material can withstand. Many materials such as paper, elastic materials, composite, fabric, and materials used in spacecraft undergo tensile tests. Then, tension test is performed on mild steel and high tensile steel to determine the properties like Young modulus, ultimate strength, and the percentage elongation. In the tension test, a steel rod is subjected to tension load by the means of a universal testing machine UTM. Next, we go to the equipment of tensile test. Firstly is universal tensile machine, and second, a cutter.
For this test, we will be using four main pieces of equipment, which is a load frame, a load cell, grips, and an extensometer. A load frame houses the motor that will be creating the load that is transmitted to the specimen by moving the crosshead up on the support beams. Today, we will be using an MTS Cretacean C4 3.504 load frame. This frame is capable of transmitting up to 50 kN. Attached to the frame is the load cell. This is the device that is used to measure the force transmitted to the specimen. Today, we will be using an MTS 10 kN load cell. Grips are attached to the load cell and the base of frame. Today, we will be using MTS Advantage Wedge grips. These are mechanic wedge grips. They are easy to use and do not require any additional equipment such as pumps. After the specimen is placed in the grip, an extensometer will be attached. An extensometer is a device that is used to measure the elongation of the sample. Now you may be thinking, why can't the load frame be used to measure the elongation? And well, you are right. The crosshead will measure elongation. It will be not as accurate. There are too many other pieces of equipment between the crosshead and the bottom of the load frame to provide a reliable result for the elongation of only the specimen. Therefore, an extensometer placed directly on the specimen is highly recommended and often required by some standards. It is also worth noting that all of this equipment can be calibrated to the respective ASTM and ISO standards. The specimen is placed in the testing area. The Advantage Wedge grip help ensure proper alignment and help minimize the preload on the specimen. Now, the test is set up. We have to set up on the software. Today, we will be using the MTS test suite. We will be using the pre-made template, EM Tension Simplified. Each of these boxes represents a comment. As we work our way down the procedure, the comment gets more and more complex using parallel path for break detection and data acquisition. This test will begin once we click the green play button. The crosshead will begin to move and the data collection will begin. After the test is complete, we can remove the specimen and the extensometer from the test space and return the load frame to its zero position. That's all from me. Thank you.
The relation between the stress and the strain for the given material can be found experimentally. These legs take the spring and stretch by apply the force. This causes the change in the length spring. Now change the force applied and gain note of the change length of the spring. Record the change in length, the strain for the difference, then plot the graph between the stress on the y-axis and the strain on the x-axis. The curve so obtained helps us to understand how a given material deforms with increased load force. From the graph, we can see that stress and strain has linear relationship between point O to A. Stress is directly proportional to the strength in between O to A region. Hooke's law stress strain not directly proportionally. The point A stress is not in linear relation to strain. It's not proportional beyond point A. Stress at point A is known as proportional limit. The Hooke's law is valid up to point A. Slope of line OA represents Young's modulus or modulus of elasticity E. It can be calculated as stress by strain proportional limit. There is increased force, the stress, the strain also increase. The body region is ilinear dimension when the applied for process remove. In this region equal as elastic region. A solid behave as a elastic body. In the region A to B, the stress and strain are not linearly proportional. The body returns to the original dimension when the load is removed. The point B is curved equal as yield point or also equal as elastic limit and the corresponding stress equal as yield strength of the load increase further the stress develops as see the yield strength. The straining increase rapidly even through small change in the stress. It is represent the curve as BD. When the loads removed, shares some points as C between B and D, the body not region its original dimension. This is a case even when the stress is zero, the stress not zero. A material has to have permanent deformation or permanent set. This deformation set to be plastic deformation and this deformation as plastic region. A point D on the graph is still ultimate tensile strength SU of the material. B on the point additional product even by reduce apply force and fracture curve point desert point E. And if the ultimate range and fracture point D and E are close, the material is to be brittle.
Result and analysis. The data obtained was used to calculate stress and strain. Stress equal to force divide area. Strain equals to change in length divide original length. Area. The gauge length for the two specimens was 50 mm while the average diameter of steel was 9.92 mm and that of nylon was 10.04 mm. The materials were of virtually the same diameter. Tensile strength equals to 6.8 times 107 N divide M2. Yield stress Y equal to 5.9 times 107 N divide M2 Young's modulus. The conclusion. The tensile test of steel and nylon had consistent and accurate results. It was shown that the strength and stiffness properties of steel were much higher than those of nylon. The experimental results for the materials properties tests of the two specimens were close to the established values. This shows that the test procedure used was accurate and the material tests were free of major flaws. The slight variations of the result from the established value were probably due to instrumental error and variations of the atomic structure properties of the materials.
Assalamualaikum warahmatullahi wabarakatuh. Today I'm Nohani Safia binti Muhammad Hafizi and my group will be present about brick bonding. In the ancient period, people constructed buildings with the help of stones and lime mortar. But shifting the huge stones was a very tedious process, as the sledge were pulled by a team of laborers and the tracks were kept waxed in order to reduce friction. Slowly, people started to use the lightweight bricks and cement mortar for the construction of buildings. In this video, we will learn about brick bonds. A brick bond refers to a specific pattern of arranging bricks to ensure structural stability. It is determined by a position of each brick in the every successive course of the wall. Here are a couple of useful words to learn. A header is a brick laid horizontally with its smaller surface towards the front of the wall. The objective is the bond are to achieve the height of the strength to be able to divide loads. A course of headers is one in which all of the bricks are laid widthwise. A stretcher is a brick laid horizontally with its longer surface towards the front of the wall. A course of stretchers is one in which all of the bricks are laid lengthwise. A mortar bed is the layer of mortar which a course of bricks is laid. A perpen is the vertical layer of mortar at the joint between two bricks. They ensure that the bricks is the same course are held together. A queen closer is a brick cut in half lengthwise. The coin is the corner brick where two walls intersect. An essential rule which everyone follows is to always offset the purpose of neighboring courses. This breaks the load evenly, preventing the risk of the structural failure. In this bonding process, we will be using the spirit level. A spirit level consists of 2 or 3 tubes filled with the liquid such as ethanol and the angle bubble of the air suspended in the opposite direction from gravitation pull tool. That's all from me. Thank you.
The procedure of brick bonding is first stretcher bond. A stretcher is a brick laid horizontally with its longest surface towards the front of the wall. A course of stretchers is one in which all of the bricks are laid lengthwise. A mortar bed is a layer of mortar which a course of bricks is laid. A perpen is the vertical layer of mortar at the joint between two bricks. They ensure that bricks in the same course are held together. A queen closer is a brick cut in half lengthwise. The coin is a corner brick where two walls intersect. An essential rule while everyone follows is to always offset the purpose of neighboring courses. English bond. This alternates courses of stretchers and headers with the alternating stretch course being offset by half a brick. The stretchers are centered on the joints between the stretchers below them so that the alternating stretcher courses are aligned. Staggering stretches enables patterns to be picked out in different texture or color bricks. Spirit level. Spirit level is a device which is used to check the level of surface, especially surface tables. The spirit level is a basic bubble instrument such like it is an angular measuring device in which the bubble always moves to the highest point of a glass via mounted top surface on spirit level. Spirit level is easy to measuring device. We just have to trace bubble movement. For example, in our figure, label cover 2 digit of a scale of one side. That means actual inclination is 0.02 per unit. The base of spirit level is called the reference plane. It sits on the machine part of which straightness or flatness is to be determined. When the base is horizontal, the bubble rests at the center of the graduate scale, which is engraved on the glass. To use the spirit level, place it on the surface whose level you would like to check. Wait for the bubble to settle and ensure that it is properly centered in the tube. If the bubble is not centered, make adjustment it indicate a level surface. You can do this by varying the thickness of mortar or by applying pressure on the brick tower hands or a towel. Change of the position of the spirit level to make sure that AI conveys an accurate reading. When measuring the comparative level between two distant objects beyond the reach of the spirit level, you may place it on top of a straight edge to bridge the gap. If the bubble indicates an uneven surface, remove the spirit level and make the necessary adjustment before taking a second reading. Make sure that you take your reading from a right angle in order to avoid error. You have now learned to use a spirit level.
Next, we go through at the construction method. Firstly, stretcher bond. Stretcher bond in the brick is the simplest repeating pattern, but the limitation of stretcher bond is that it cannot make effective bonding with adjacent brick in full width thick brick walls. They are suitable use only for one half brick. These walls such as for the construction half brick thick partition wall. Walls constructed with stretcher bonds are not stable enough to stand alone in case of longer span and heat. Thus, they then need supporting structure such as brick masonry columns at regular intervals. Stretcher bonds are commonly used in the steel or reinforced concrete frame structure as the outer facing. These are also used as the outer facing of cavity walls. Other common application of such walls are the boundary walls, garden, and another else. Secondly, English bond. English bond is header are laid center on the stretcher in course below and each alternate row is vertically aligned. To break the continuity of vertical joint, coin looser is used in the beginning and end of a wall after first header. A coin close is a brick cut lengthwise into two halves and used at corner in brick walls. Next, advantage stretcher bond and disadvantage of stretcher bond. Advantage of stretcher bond is while stretcher bond is used for the construction of wall of half brick thickness, where this bond is used for the construction of wall with full brick thickness. In this bond, the overlap is kept equal to 1/2 width of the brick. For this purpose, 3/4 brick beds are used in alternate course as coins. Disadvantage of stretcher bond. Stretcher bond cannot be used in case full width thick brick walls as they are suitable only for half brick thick walls such as the partition walls. Next, advantage of English bond. This type of arrangement help to increase the longitudinal stability of the thick walls built in English bond. In this pattern of bonding, the space between the all external structure of a wall is filled using brick inclined to the face of the wall. Disadvantage of English bond: quick oxidation, easily water and stained.
Stretcher bond, the most commonly used bond in the UK. A pattern is made only using stretchers, with the joints on each course center above and below by half a brick. This type of bonding is not particularly strong. A variation is the racking stretcher bond. The overlap between bricks is usually a third or a quarter of brick instead of half a brick. Is an exceptional. The English bond. This is a pattern formed by laying alternate course of stretchers and headers. The joint between the stretchers are centered on the head in the course below. This is one of the strongest bonds but requires more facing bricks than other bonds. It is exceptional. Therefore, we see that the manner of overlapping bricks for construction of wall is called brick bond. Many types of bonds are used in different ways for construction of brick wall or brick pillars. Good brick bonds can ensure the strength of a building and aesthetic beauty of brick walls, brick pillar, and entire brickworks depends on the quality of bonds. Thus, bond in brickworks is of utmost importance. Assalamualaikum and hi. Today we will present about structure item. The introduction. Building structure means the foundation for floor, ceiling slabs, roof, exterior walls, exterior glass and mullions, columns, beams, shelf including elevator, shaft, stairs, stairwells, elevator, building mechanical, electric and telephone closet, common areas, public areas and any other structure component in the building. The building structure is whole improvement and similar improvement to the objective is structural system in the building construction, the particular method of assembling and constructing structural elements of the building so that they support and transmit apply load safely to the ground without exceeding the allowable stress in the members. So my group choose of structure material is concrete. I want make important introduction of reinforced concrete. As we know that concrete in general is made of coarse aggregate, fine aggregate, cement and water. The advantage of concrete is very strong in compression. However, the bad thing of the concrete is weak in tension. For the compression way is the concrete will do their job. However, for the tension, it will fail easily because as we said, the tension strength of concrete is very low. So what we do is introduce of the material mainly in the tensile region. Reinforced is be concrete. Material stand up to be steel for mainly reason. First, for having high tensile strength. Then, the second, it is the concrete and steel have same coefficient of thermal expansion. In concrete structure, we can learn first single reinforcement of beams, then double reinforcement of beams. After that, T-beam design, then design of short columns with or without eccentricity, and the last, design of one-way slabs, rib or solid.
Next, we go to the equipment and materials. This is a list of building materials. Many types of building material are used in the construction industry to create buildings and structure. These categories of materials and products are used by architects and construction project managers to specify the materials and method used for building project. Some building materials like cold rolled steel farming and consider modern method of construction and traditional method like blockwork and timber. Many building materials have variety of use. Therefore, it is always a good idea to consult the manufacturer to check if a product is best suited to your requirement. And equipment. Formwork. Firstly, circular saw, handsaw, hammer, nail, tape and L-shape. For beam reinforcement, RC cutter, tape, bar bending, workbench, pincher and tie hook. For concrete is digital balance, bucket, scope, shovel, mixer and mixing tray. The material, formwork. Firstly, must be plywood 10 mm and timber 2x1. Beam reinforcement. Firstly, must be RC bar diameter 10 and link diameter 6. Secondly is wire. For concrete, must be cement, sand, aggregate and water.
The procedure of concrete is in the production of concrete are batching or measurement of material, mixing, transporting, pressing of compacting, curing and finishing. The first process in manufacture of concrete is bleaching of materials. Once the grades of concrete are known, the quantities of materials should be batched. Accordingly, the required quantities of cement, fine aggregate, coarse aggregate, and water are measured with an accuracy of plus or minus 3% of batch quantity. If any admixture are to be at its accuracy should be less or minus 5% of the batch quantity. Mixing. Once the required quantities are batched, the materials are mixed thoroughly to make the concrete mass homogeneous and uniform in color. At the mixing should be such that the aggregate particles should be coated with the cement paste and all the ingredients of the concrete should blend into a uniform mass. Transport. Once the ingredients are mixed thoroughly, it should be transported to the place of deposition at the earliest without the loss of homogeneity obtained at the time of mixing. In an average, the concrete should be transported within 1 hour if no agitators are available in the transporting machine, whereas if trucks with an agitator are used, the maximum of 2 hours from the time of mixing is permitted, and also sufficient care should be taken such that segregation does not take place during transportation and placement. Placing. Once the fresh concrete is transported to the place, the concrete should be placed with care in order to achieve good quality concrete. The quality of concrete should be secured such the homogeneity achieved during mixing is maintained, and the segregation of concrete during transportation should be avoided. The allowable delay for dry mix in hot weather condition is half to 1 hour on for wet mix. In cold weather condition, it may be several hours. After that, compaction. After the concrete is placed in the desired location, it should be sufficiently compacted. Compaction consolidates fresh concrete within the molds of frameworks and around embedded parts and reinforcement steels, as there will be a considerable quantity of air entrapped in concrete during its production, and also there will be a possibility of segregation of concrete. Both of these may affect the quality of concrete.
Assalamualaikum warahmatullahi wabarakatuh. Next, for the observation of results, design mix is important to the properties of concrete. Even varying the water content by a small amount can have major impact on strength, not to mention the workability and even the finished appearance of the concrete. In addition, concrete itself has a surprisingly short lifespan. After 20 to 30 years, natural processes like concrete shrinkage, excessive freezing, and thawing and heavy loads can trigger cracking. And it's not just big breaks that count, tiny cracks can be just as dangerous. Concrete usually used as secondary support around steep reinforcement. In this concrete, even small cracks can channel water, oxygen, and carbon dioxide that corrodes the steel and lead to disastrous collapse. On structures like bridges and highways that constantly induce detecting this problem before they lead to catastrophe becomes a huge and costly challenge, but not doing so would also endanger thousands of lives. So, for the conclusion, concrete is one of the most versatile and widely used construction materials on earth. It's strong, durable, low maintenance, fire resistant, simple to use, and can be made to fit any size or shape, from the unfathomably massive to the humble stepping stone. However, none of those other advantages would matter without this. It's cheap. Compared to other materials, concrete is a bargain, and it's easy to see why if we look at what it's made of. There is so much complexity to the topic of concrete, partly because it has so many applications, from the skyscrapers to canoes and everything in between. In fact, no matter where you are really more than a few feet from concrete, a fact that is inexplicably a source of great comfort to me. That's all from me. Thank you.
Assalamualaikum warahmatullahi ta'ala wabarakatuh. Introduction of Macintosh Prop is a thorough soil investigation is required before any construction, building or project begins. It is used to help determine soil properties at a construction site and also help to establish the soil conditions and if it is strong enough for construction. One of the tools that can be used for research purpose, especially for soil investigation, is Macintosh probe. Macintosh probe test is carried out to determine the strength of the soil. A Macintosh probe is a lightweight portable penetrometer that is designed to be a tool to investigate the soil bearing capacity. The Macintosh probe is a lightweight dynamic penetrometer and a considerably faster and cheaper tool than boring, particularly when the depth of exploration is moderate and the soils being investigated are soft or loose. Macintosh probe is typically utilized in preliminary soil investigation to accumulate the underlying shear strength directly through correlations and consistency of the subsoil layering for very soft soil. For that reason, Macintosh probe test is very important to the construction world because it affects the whole construction of the structure. The main objective of this research is to make remapping the structure component of block so as to evaluate the building structural integrity. Macintosh probe is a tool used for research purpose, especially for soil investigation. Macintosh probe test is carried out to determine the bearing capacity, which is the strength of the soil. The result obtained from the test provides a rough estimation of the soil layer at a point.
Now we move to the procedure of the probe Macintosh test. Material preparation. First, all equipment for the test are assembled. The cone diameter is measured in SI unit. Now we move to the procedure of the probe Macintosh test. Material preparation. First, all equipment for the test are assembled. The cone diameter is measured in SI unit. Second, the boring rods and hammer are joined using the rod coupling. Brace is swept up for the easy assembles later. Then, distance of 0.3 meter is measured and marked on the rod start from the tip of cone. After that, the equipment is set up on the ground. In addition, the hammer is pulled until it reaches the maximum. The hammer is dropped freely to drive the cone into the soils. After that, the sum of the number of blows for penetration of 0.3 meter is recorded in data sheet. Moreover, the hammer is taken off on glass of 0.3 meter of each rod and join the existing rod with another rod, and lastly the hammer. The blow is continued and consistent stop when the blow is more than 400 for 0.3 meter penetration, and also when the depth reach. Besides that, pull the rod using lifting tools after the penetration reach the requirements. Furthermore, the equipment is disassembled and prepared as a small metal dish to collect soils that clinging the rods. Afterwards, record the weight of empty dish. Then record the soil sample in the same empty dish. Additionally, place the dish in the oven to dry out moisture in soils for 24 hours. Lastly, take out the soil sample and all data will be recorded in the sheet.
Okay, next we move to the results and discussion. First, the preliminary test. So we can see the depth 0 to 0.3, the number of blows 140 blows, and the cumulative number of blows 140 blows. And then we can say that 0 to 2.4 depth, and the last number of blows is 400, and the cumulative number of blows is 1518. Okay, next, this is the cumulative number of blows versus the depth graph. And next is the graph of estimation of layer of soil. This is for layer A, layer B, and layer C. The soil bearing capacity from the calculation that have been calculated for the number of blows per 0.3 meter, layer A accumulates a total number of 110 blows per 0.3 meter to reach to the layer B. Layer B give a total number of 148 blows per 0.3 meter to reach the lazy, and the lazy give a total number of 296 blows. All of these results have exceeding the limitation of the standard bearing capacity graph, which only limited to 108 blows per 0.3 meter. So this is the figure of 4 that showed the standard bearing capacity graph. And then we move to the progress test. For the test 1, the progress test that you can see of the depth of 0 to 0.3 and the 0.3 to 0.6, and the number of blows is 313 and 400 blows, and the cumulative number of blows is 313 and 713. So this is the cumulative number of blows versus draft for the test 1. And test 2, the depth are still same, and this is the cumulative number of blows for test 2. So for the test 3, just have one of the depth which is 0 to 0.3, and the number of blows is 400, and the cumulative number is also 400. And this is the cumulative number of blows versus depth graph for test 3. And test 4 have 0 to 0.3, 0.3 to 0.6, 0.6 to 0.9, and the number of blows is 149, 285, and 400. And the cumulative number of blows 149, 434, and 834. And this is the cumulative number of blows for test 4. And this is the progress that presented with of the test 5. And next is the cumulative number of blows versus depth graph for test 5, which is without NGMP and with NGMP. And this is also the same test. So this is the test 6 with NGMP and without NGMP, and this is the cumulative number of blows. And lastly is test 7. That's the same. And lastly, for the discussion for preliminary results. From the preliminary results obtained, it is safe to say that the soil in block 14 are too hard for the present Macintosh Pro to operate. The results shows that the number of blows per 0.3 meter are far greater than the limitation of the standard bearing capacity graph. With this limitation problem, the suggestion to overcome this problem is by changing the location of the study from block 14 to the construction site behind the UTP. This is due to the expected soft layer that have been excavated at the construction sites. From here onwards, the study can flow nicely without any obstacle to obtain more data to be analyzed. Furthermore, the factor that might lead to the lack of force to drive the rod into the soil, excluding the hard layer factor, are probably caused by the following, which is a limitation energy of the user. The verticality of the toe itself is inaccurate, and lastly, the drop of the 4.5 kg dead weight is not from the maximum height of 300 millimeter. And this is the progress result. From the result obtained, it's safe to say that the soil of a part for the test 1 is well compact. And then for the progress result presented by Macintosh Pro for test 5 until 7, the test of the present Macintosh Pro and the NGMP had been changed to block 14 to give a rough estimation of 3 layer. And lastly this is the cumulative number of blows versus depth graph for test 5 until test 7. So that's all from me. Thank you.
Next, we go through to the advantage and disadvantage of Prof Macintosh. Firstly, advantage. The size of a small, lightweight device causing easily handled and speed work, and tests performed yearly than tests of other sites before a project underway. Information and data were obtained more quickly, easily, and save time. The cost of handling equipment
and the use of relative cheap. And disadvantage is use limited in terms of the impact energy is too limited, and bearing capacity of soil foundation design is a development known only superficial. Next, we go through to the conclusion of Prof. McIntosh. Conclusion: JKR Prof. McIntosh can be used to determine the thickness of unsuitable material to be removed and also for preliminary design of embankment limited to about 15 meters and must be record no off blow. Then correlated to establish chart to determine bearing capacity of soil. McIntosh probe, which has 30-degree cones penetrometer, while JKR probes has 60-degree cones penetrometer. This is light dynamic test, and the cones is driven directly into the soil by driving a hammer 5 kg. Wick dropping through a free head of 280 mm, and the probe is unable to penetrate into medium strain soil and gravelly ground. That's all from us. Assalamualaikum warahmatullahi wabarakatuh.